And I believe we are all set. So, can everybody see the slide? Faculty Lightning Talks, April 27, 2023. Great. My name is Rob Reed. I'm the worldwide university engagement person for the company called Databricks. Who am I? I'm this guy. Less important than who are we as a community. And I've had the privilege of working with some of you for more than 3 years now, a community of educators, students, and tech industry professionals who want to learn and build with Databricks. And I think of that in terms of a data science machine learning notebook that connects to cloud resources. So that's who we are. And right now, this community of people is about 600 universities representing about 60,000 students. So what are we going to talk about today? We've got 5 faculty members talking about teaching analytics at scale, what they teach in their course, how they use tools like Databricks, Amazon, and Vocarium, and most importantly, key points and observations with for other instructors. Each faculty member will have 5 to 10 minutes to cover their material, and I'll run the chat window as a moderator, and it's going to be a little. I usually have 2 people helping with this, so if I'm a little scattered, I'm trying to look at the questions and do the moderation at the same time. We'll have 10 to 15 minutes of Q&A at the end, and the sequence of speakers will be Lloyd, then Su-Hong, then Jong-Wook, then Ben, and then Diane to wrap it up. So with that, Lloyd, I think I'm just going to make you just see if you can present, and if not, I'll just make you the host. Take it away, Lloyd.
All right. I take it we have a slide that says teaching with Databricks.
Yes.
Good. All right. So, yep, as Rob sort of did a little bit of a pre-introduction, my name is Lloyd Palom. I'm an adjunct professor at the University of Rochester here in upstate New York. And about 4 years ago, we created a new class within the curriculum at the University of Rochester Data Science Institute called Data Science at Scale. And this course was purpose-built to sort of put part of the curriculum firmly on a practical application of data science and how you do that at scale. Whereas many of our other courses in the curriculum focus on theoretical aspects and are what I would call deep dive on narrow subjects. This course is more of a broad-based introduction to all of the things that comprise building data science or data applications at scale using data science. And so the course materials that we use are pretty closely aligned with what Databricks has for materials as well. Learning Spark was written, of course, by some folks at Databricks. And then there's an early release book that we also touch on that delves into the Delta Lake technology. But we introduce Spark and Delta Lake. You'll see in a coming slide some of the other broader aspects that we cover. But we use sort of a tandem between the Databricks Community Edition that we get the students started on early part of the course. And then by the end of the course, we're running a larger group project within the Databricks Enterprise Edition. And you'll see later on in my talk, this is really where we're making some improvements most recently that are quite impactful. And in terms of how we teach this material, it's really a combination of lecture content, presentations, mostly centered around the conceptual introduction to a lot of these things. And then there's a lot of notebook and coding walkthroughs that give the students the practical introduction to those concepts and how they manifest themselves in code and projects. And then we lead them up to a final project that's fairly comprehensive at the end of the class. This picture is a really good, say it all with one picture. We essentially introduce the students to the conceptual process of building a data intensive application. And you can kind of see that along the top. None of this is probably that new for people. It really has become prototypical in terms of the way that you would talk about the process of building one of these applications. But then the other thing that we're doing is we're marrying that up with specific platforms, and in particular, the ones that are available on Databricks Enterprise Edition. And it's the combination of Spark and all the tooling and orchestration of Spark, along with ML Ops and ML Flow and data warehousing feature storage within Delta Lake. And so the students become aware of these three very specific platforms that they can employ to run that process that we're talking about during this class. Yeah, so how do we do it? It's really broken down into modules. So we start out talking about data intensive applications in general, and then we proceed through, learning Spark. We're moving pretty rapidly because the students are expected to know SQL and Python. So we're not really stopping and smelling the roses in terms of code development or SQL. We're moving, really fast and focusing on how to use Spark. Then we graduate into Delta Lakes and machine learning operations with ML Flow. And then finally, in the last 6 weeks or so of the course, we do an end-to-end application that touches every aspect of that process and the platform elements that we've been talking about. Yeah, so this course is 4 years old. I started working with Rob actually 4 years ago. I think this is the fourth time that we've offered the course. We steered through COVID and everything, doing it remotely, so there was some hiccups in the road. But up until this year, we've been managing everything in what I would call a very manual, hands-on way. Like I was setting up student accounts using scripts and the Databricks command line interface. Each student would get assigned to groups within Databricks. Again, all this is being done with bash scripts and, sort of orchestrating the whole thing behind the scenes, setting up AWS resources in terms of what clusters were available for students and making sure they had access to just the ones that we would like them to use, trying to provision S3 buckets and things like that for data that's specific for student projects. There was a lot of system administration between AWS and Databricks going on to orchestrate this course. And I guess the real upshot of why that is important is that it really was stymieing the discussion, I think, around the university to use this platform and approach more broadly. So without me and some of my fellow professors that were focused solely on this course doing all this administration, it wasn't really moving beyond, this course. And so what we were able to do this semester that's kind of exciting is we brought a company, Vicarium, into the mix. Rob had spearheaded a discussion with them, and then I, was eager to raise my hand and become a beta or a prototype for this. And essentially what this allows us to do is we're moving into a world where our learning management system, we're at the University of Rochester, that's Blackboard. There's other learning management systems, of course, that many of you are probably using that aren't Blackboard that would function similarly. And then Vicarium is essentially a learning platform that plugs into the element to Blackboard and gives us essentially the ability to make assignments and projects and form groups, and students are essentially automatically enrolled through the single sign-on capability of Blackboard. And then Vicarium takes control of Databricks through all of the API interaction that you can use to manage Databricks. So this is essentially relieving all of the manual steps that I've been doing on the course over the last 3 years and making this sort of seamlessly integrated into what the university's already using for class management and learning management across all the courses at U of R. So we have people in the business school, for instance, that teach analytics, business intelligence type things, and they probably would benefit and are interested in Databricks. And it wouldn't be until it got to be this seamless that they would be able to tackle that. And
hey, Lloyd,
Yeah.
Oh, I just want to point out for the folks on the call, we've got Sanjay and John Deneen from Vocarium on the call as well. And I just want to give a shout out to Sanjay being able to meet face to face in San Francisco a couple of months ago and just really having an amazing conversation about doing exactly this. We've got Jay Shan from Miami University in Ohio, and I remember he was so excited to get access to Databricks because it was, and the dogs are excited too, because Databricks was a simpler way for him to teach, simpler than at the time Cloudera. And for me, Vocarium as an interface to Databricks and AWS is like yet another step forward to where you can focus on pedagogy and cognition versus knitting together the tech pieces on the back end. So just wanted to point that out. So it's Sanjay Srivastava and John Deneen. So reach out to them into the chat directly if you'd like and have questions. But Lloyd was, we trusted Lloyd because we had a couple of years of experience, and knowing that Lloyd could get the icky tech bits done even without Vocarium, but it seems to have been a fairly wonderful pilot. And for me, it's something that allows this type of effort to scale. All right, I'll be quiet. Back to you, Lloyd. Thank you.
Yeah, amen. That's really the essence of it. The other thing that is maybe a little subtle here, but it really allows all these different software pieces allow it to become more seamless. The other thing that we were doing in previous semesters was, running around by hook or crook, garnering enough AWS credits to sort of bankroll the class. And so this puts us in a position where we can centralize, or Databricks can centralize, the cost of running these university programs on top of the Databricks platform. And I think it'll get a lot easier to work also with AWS or the preferred cloud providers that are underneath all this. It sort of makes it easier as a professor focused on education to get out of the nuts and bolts of setting up all these software platforms. And so far with Vocarium this semester, it's sort of been our beta run. It's running quite well. In fact, the students are in the last probably 2 weeks-ish, 10 days even, of their final project. So we're really heavily using the platform right now, and it seems to be quite good. So we're having a good experience. So yeah, that's the quick introduction to data science at scale at the University of Rochester and how we're leveraging Databricks and now Vocarium to do all this stuff.
And I think, yes, Suhong, I think you're up next. And I just wanted to also point out that for those on the call that are using Databricks on AWS, finding the credits, managing the credits, watching the budget, that's another piece of this that takes a huge amount of time and overhead. And the Vocarium layer helps abstract away some of that. We still have to watch and manage the AWS costs, but I think Thanksgiving of last year, I lost the rest of my hair because our AWS credits for, I think, 25 or 30 classes ran out before the end of the semester. And we had a 6-day gap between new credits and the old credits running out. And I was just horrified because the classes had just kind of had to grind to a halt or cover their AWS charges out of pocket. And finding a way to get around those discontinuities and some of the budgeting issues if you've got a hard ceiling on your AWS costs. It's about student learning, and that gets in the way of that. So it's another. I'm so excited. So anyway, Suhong, I'll turn it over to you. And again, any questions, please post in the chat.
Okay, so today what I'm going to talk about is I'm going to talk about my experience using Databricks in teacher my courses, and I also wanted to introduce some of cool visualization feature I think Databricks just introduced recently. So basically, this is what I'm going to cover in my talk. So a little bit of my background. I'm at Bryant University since 2001. Currently has been working here for about 20 years. I teach database, NoSQL database, big data analytics, data visualization, and also data science capstone. So my research area is basically currently in social media, Twitter analytics, using some of natural language processing, including sentiment, emotion analysis, topic modeling, network analytics. So a little bit of background where we're interested in explore Databricks because in 2017, we started a bachelor degree in data science. And then actually we're launching 2 new programs in the coming fall, a Master of Science in Data Science, a Master of Science in Business Analytics. So actually our whole curriculum is based on the open source, and we definitely teach students how to analyze big data on a distributed platform is quite important. So we have a big data analytics, a deep learning, natural language processing course at graduate and also undergraduate, graduate level. So just to give you some background, I think I'm also has been using Databricks. I could not remember 3 or 4 years ago. And so before that, I'm really struggling teaching students like big data. I tried all the different platforms, Cloudera, QuickStart, Teradata, Aster, and then so there's also has other platform available like I know Amazon has a map, they have a similar kind of map reduce function. So the problem with all the other platform is because the student needed to install the software on their computer. So I'm running into a lot of issue with installation, trying to help students debug their problem. So I wanted to say more than half of my course has been like showing students, like help student debugging. So until I know the Databricks come in to save my life. So I want to show you, I have incorporated Databricks in 2 courses. One is the big data analytics, another is data science capstone. So basically, my approach is very similar, just like what Lloyd has been discussed in his presentation. So I started with the introduction of big data architecture, like what we call Spark SQL, Spark data frame, Spark streaming, and then we also cover machine learning part. So how I run this is I want to show you like in terms of how I started with like a Databricks community edition, and with the support of Rob, and be able to run big data set on Databricks Enterprise. And then this semester, I'm a pilot testing application like called Cloud Lab. Cloud Lab helped me to set up a Databricks cluster to run my course. So in my big data analytics course, so actually Databricks Community Edition is free. Anyone can request an account. It's very easy to set up. You just need to go to Databricks like website, and then you submit some information, and then automatically you can use it. So I think it would be good like to teach students basic function in Spark. Like so I have used like a Databricks Community Edition in the first half of my semester. So they learn all the like SQL data, how to manipulate a data frame, streaming, and part of the Databricks Community Edition is only give you one single node. So if you have a big data set, it would not be possible. So, and in my second half of the class, usually students work on a real world project from our corporate partner. So they need a more powerful architecture. So with the help of Rob, so Rob, I have been fortunate to give access to a Databricks Enterprise. So, and in this way, actually, I got an account. I can Like usually what I do is I have a 30 students in my class. I create 2 shared clusters. So basically I put 15 students like in each cluster, and then I need to install necessary library to the cluster. I need like for the students, they can start and terminate a cluster, but they are not allowed to create their own cluster. And because I put my data in the AWS S3 storage, and then I need to mount my data to the Databricks so students can automatically access. So, and then advantage of doing this is there's no need for me to install any software, and there's no need to supply a credit card, and it's very easy to use. And then the student was able to access a cluster with a click of a button. So, and this is how I've been running, like I've been using Databricks. But for me, it still involves some administration tasks, just like Lloyd mentioned. You're managing the cluster, and then you need to like assign the student to this cluster. So, and then I think this semester, and with the help of Rob, I'm doing a pilot test by using a service provided by Cloud Lab. So what Cloud Lab is doing is Cloud Lab is going to like create a class for my course. So I just basically I just want to share the steps to set up, and so I got connected with the Cloud Lab. So before the class, actually I need to figure out the configuration for my class. Like based on the number of students I have, I need to tell them what number of worker, type of drive, and the configuration for the driver and worker I need. And then so basically because I want to be able to student access my AWS S3 storage. So again, I had a meeting with them because they needed they need to help me, like they look at the configuration for my AWS and build this link. But they are saying in the future they can provide S3 storage for instructor use. So there's no need for this step anymore. And then basically, so they are going to send you the cluster they created. You can do some testing. And the final step is basically before the class start, I send the student list to the Cloud Lab. They just authorize all the students to the cluster. So in this semester, I have a small class lab because this is a capstone, data science capstone I'm teaching. So they create only one single shared cluster. And for the whole class to use, I have 15 students. So all the students were just sharing the same cluster. So I want to share you like my experience about trying this Cloud Lab. And I want to say that once you log in, the interface is identical. Like there's no any additional learning is needed. Once like Cloud Lab give you a link, you log in, it's familiar Databricks interface. And then for me, there's no need to create a cluster, manage a student account. The only thing I needed to do is just send my like a list of students, and then I'm all set. So I think this is a big challenge. I think the big advantage is because in the past, if I'm managing the class, usually Rob give us like credit for us to use AWS, because the Databricks, like the back end, all the like virtual machine, all the classes running on AWS, because we have a limited credit here. So I need every time periodically, I need to check like something like a credit I still left. Can I survive the whole semester? Sometimes I need a bag Rob to say, can you give me another 1,000? I'm running out of it. But this semester, I'm very happy because I'm not like checking any credit limit. The whole thing is handled by Cloud Lab. So some of the challenge I wanted to say is figure out, like based on the class that you have, what would be the proper configuration. So when I send this to Cloud Lab, I just say I have no idea. This is the first time. So in the middle of a semester, because some students did say it take very long for them to run the machine learning model. So I contacted the Cloud Lab. They are able to like increase, like maybe they have increased number of nodes in the cluster, so which like speed up the student processing. So second one is a challenge. You have all the students on the same cluster is if they're all running the running the machine learning model at the same time, especially usually happen during the class time, and usually it takes much longer. Like for some of a machine learning model, they are saying outside of class they only need 2 minutes, and in the classroom sometimes they need 20 minutes to run. So yeah, definitely like this is some, maybe it's not anything related to Cloud Lab. It's all like if it's a shared cluster, definitely if a lot of people are running the application at the same time, is going to slow down. So I want to say my overall experience are very positive. So basically another thing I want to show you, like what I really like Databricks is enable sharing and collaboration. So each Databricks and the workplace, there's a folder, shared folder. So anything you drag and that folder, actually all the students can see. So for me, it's very convenient, and like for all the course material, if I want to share with the student, I just put it in that shared folder. And for the students, they can also, like they're working on the group project, and then they can also share their notebook with their team member. And then the student team, they can work on the same notebook. So definitely like Databricks, like enable this collaboration among the students. And as an instructor, actually, you can see all notebooks created by students because you have instructor account. So sometimes it may be helpful, like you giving students some assignment, you say, I can just log in the Databricks, I can check, like I can just see, I can also monitor to see who is more active, right? They're more actively like working on their project because they access more. So so basically in terms of data science capstone, so I really appreciate the Databricks. I think because for the data science capstone, all the students, like they work with the real world project. Sometimes a company give us like millions of data sets. It's just impossible to run on a single machine and using the Python code. So I just want to give you some of the real world project student has been running on Databricks. So I just give example. This is all real company. Student has identified a cross-sell opportunity, especially during the pandemic, where I work for a traveling company because their travel just stopped because of the pandemic. So they're trying to see, like, identify cross-sell opportunity. And then we also have built an interesting different model for different company. We profile, predict loyal customers, and we help an insurance company to predict emergence of a sinkhole, so they can they know what primer they should give to the customer, like for their house insurance. And we have a predict machine failure rate. And recently, we also help a healthcare organization predict patient at the risk of type 2 diabetes. And my favorite project is the predict number of bugs on a leaf for a local farm. So they have people manually count number of bugs on the leaf. They want to evaluate all the treatment chemical, which one is more effective in killing the bug for their lettuce. So they grow a lot of lettuce and supply many local supermarkets. So, and then the last thing I wanted to mention is I don't know when I think the Databricks maybe not recently, at least maybe 6 months before, I think they totally enhanced their visualization. So they have a much more visualization to use. I think what I like Databricks is you can run everything on its platform. not like, so you start with, you have all the data coming from like a different source. You can use the Databricks to do the data pre-processing, data cleaning, and then you can build the model. You can run the machine learning model, you can fine tune the model, and finally you can do the visualization. You can even put the visualization on a dashboard. So there's no need for you. I use Python, I run my machine learning model, I need to export my data. I may use Tableau, Power BI to do so. I just want to show you, like, I really like this very, like Sankey chart, water cloud. I just give you, like, this is created, you don't need to write any code. Like if you have data, so this, we just show like this for a company, we want to see number of loyal customer, like from like 20 years ago until today. So it's nicely show, you can see, you can have multiple like a pie chart, definitely we can see the trend. So again, in this stack, the bar chart is also looks really nice. And then because we look at for each year, for the loyal customer, what are their like top investment objectives? And then you can see this another way. So this is like, they also have you can create this kind of, we call the heat map. So my favorite one is like water cloud. You don't need to write any code. This is just like say, once you have your data in Databricks, within one, it can allow you to create a very good, appealing visualization. My favorite one is Sankey chart. And now you can create a Sankey chart using maybe Tableau, but it's a lot of work. Sankey chart is very useful to showing you have multiple dimension, but you wanted to, like you have one numeric variable, so you want to see how all the dimension, like regular customer, loyal customer, what are the top fund they're buying, and then we also have to say on a yearly basis how this looks. So this is a very, we call it path analysis. This Sankey chart is also, I think, a good visualization the Databricks has added. So basically, I want to say that my future plan is I plan to incorporate more advanced content in big data analytics. In PySpark, I think they support deep learning. They also support graph analytics. So you look at the relationship among like different nodes. So and then also I want to say, like, because the Databricks also has a pretty robust SQL, like you can run the SQL. So there's a potential if you're not doing machine learning model, like for your database or data warehouse, and then you have very nice cloud-based architecture, allow you to teach students like SQL. And then, okay, so I guess this is my what I wanted to share. Okay, I'm going to stop sharing.
It's interesting. I put up on one of the first slides, 600 universities, 60,000 students in this program. So for Suhong, when somebody signs up for the Databricks University Alliance, I do a word cloud on the course or what they're trying to teach. There's like an open text field. What's interesting to me, and then you can also choose course technologies that you use in the class. 2 years ago, the biggest word in the word cloud was Spark. Right now, Spark is a distant third to Python and SQL. So the growth of visualization and the use of SQL in these data science notebooks, I think, from an academic standpoint, has continued to grow. And that's pretty exciting. The other thought, as you were talking about how you set up shared clusters and working with cloud labs to provision resources, the word dog food came to my head, because as an instructor, you're having to deal with resource optimization in a way that students, as builders of the technology, are going to have to deal with resource tweaking and optimization. And then, yeah, that was fascinating to me, and those are my observations.
So somebody are asking in the database community, in the Databricks Community Edition, can you use SQL? Definitely you can use. So every time you have data frame, you say dot display, and then it shows as a table at the bottom. There's a visualization you can access. but I do believe there's a limitation using community edition. There's I think maybe I'm not sure whether they have more advanced like a Sankey chart I just showed you, but all the basic visualization are there. That would be wonderful to teach your database, because I also taught a database. My challenge is you create this SQL, but you really like there's no way for me to visualize. For the people, it's better to visualize to understand the pattern. So in the Databricks, students write the SQL immediately, they can do the visualization. And then, so in the past, you say, I export this SQL command, I visualize in another software. So right now, everything you can do in one interface.
So I hate Community Edition not having Databricks SQL in it. That will change a year from this summer. So I'm just gonna go. This is being recorded, so maybe I'll get in trouble with Databricks legal, but it's been my goal for 3 years to get Community Edition, basically a different free trial version for academics of Databricks Premium. So that is coming. Those pieces are coming together. It's been, it irritates me, but we're getting there, and I think we finally have progress coming.
Yeah, Rob,
so I will let everybody know. Go ahead. Sorry.
Rob, I wanted to say you can use SQL because you can switch. If you have a data frame, you just say %SQL. You still can run all the SQL command. You can do the visualization. I'm just saying its visualization is limited compared with the enterprise, but all the basic visualization already there. When I teach my first half, I really also have a student create a project. My requirement is you need to visualize your results on a dashboard. In the Community Edition, you also can create a dashboard. It's so easy to do. You create all the visualization. You can just put all them in one interface, the dashboard. You can also make it as interactive. You can include the filter, right? Just like a Tableau, you say, I want to look at this particular year, and then you can filter your dashboard within the Databricks. So this is a pretty cool feature. Databricks has the best documentation. So the best way for you to learn all the visualization, just go to is the Databricks visualization documentation. It shows you like how to create all the visualization, how you create the dashboard.
Great. And there are current internal projects going on taking all of our Databricks documentation and turning it into a chat GPT like LLM. That should be progress as well, because what I would like to do is just provide you, the faculty, an interface to the documentation to where I am out of the role of middle person. So you have direct human query-based access to all of the Databricks documentation. That's coming as well. So
Rob, can I start?
yes, please. Thank you.
Okay, great. Okay, so I guess you guys can hear me and see my the note slide here, right?
Yes, we can see it.
Okay, great. Okay, so it's my great pleasure to share my experience to teach my class with the Databricks. My name is Jongwook Woo, and I'm gonna start with introducing myself, and then I have the content here for about my experience. Yeah, I've been teaching here at California State University, Los Angeles since 2002, and I'm also a director of a Big Data AI Center. And it's my great pleasure to be partner with the Databricks since 2015. And I've been involved in many projects in Hollywood, and also I work with the City of LA and City of Los Angeles too, and other universities and smart startup company like SoftGen. And let me move on. Classes that I teach using big data and AI, especially with the Databricks. I teach several big data AI related courses. One of them is CIS 4560, that is named Introduction to Big Data. And its equivalent graduate course is CIS 5200. In this class, I mostly cover the topic related to data engineering and data analysis, especially with the large scale data. But in this course, I mostly focus on Hadoop and Hive using Oracle Cloud and Amazon AWS. And my other course, another course is Business 5100, that is Introduction to Business Analytics. And I deliver general concept of data engineering analysis and big data AI for MBA students. And also I invite speakers from industry to share the cutting edge technology and cutting edge trend in this area. Especially for CIS 5560, named Introduction to Big Data Science, I deliver data science related topic, especially with the large scale data set. And the core to deliver in this course is definitely machine learning and data science. And I use the PySpark, especially with the Spark machine learning, the library. And in this course, yeah, I definitely use Databricks Community Edition and Enterprise Edition together. And I always Rob, thanks for supporting us with the Amazon AWS credit to make it happen. So in this class, I'm going to briefly go over the lab environment. Definitely the Databricks is the core to use. And especially for Enterprise Edition, based on the credit, I use Amazon. And also for visualization, I use display function of Databricks, but besides that, I use Microsoft Excel, Google Spreadsheet, and Tableau. And mostly, especially for CIS 5560 data science course, the first half of in the first half of the semester, I use community edition of Databricks because it is free, and this is like I deliver the fundamental concept of Spark. So simply I use a small data set to deliver that concept to the students. So to save the credit of AWS, we start using community edition first, and then I deliver the fundamental syntax of PySpark. And also, the ETL is very important, so I teach how to upload the data to Databricks file system, and how to create table with the data files, even though the data file is small set. And also I deliver the concept of data frame to read and write data in several file format that could be CSV, TSV, or Parquet. And this is kind of data engineering, but data analysis is another the issue that I need to deliver. So students learn how to use data frame, and also SQL, because SQL is very easy to learn and also popular in the market. So using data frame function or using SQL, the students know how to create a view or table, and how to join tables, and how to use a group by with the aggregate function, like a sum, count, average. And also they it's very easy to learn, but anyhow they learn how to use display function to visualize their data analysis result. And but again, the core of this course is to learn how to use machine learning for data science with a large scale data set. So I deliver supervised learning and unsupervised learning concept. and especially for coding, the pipelining is important for modularized code. So I mean, students learn how to use vector assembler, indexer, scalar, and also to generalize model. I deliver the concept of a cross validator and train validation split. And then to improve the performance, I mean, the accuracy of the model, I also teach how to use validator and parameter grid builder and feature. I mean, also how to score the features for the models. And based on this, the concept, you know, at the end of a semester, definitely, you know, the students use large scale data to build their own model. So for that, I built a big data cluster using the enterprise edition of Databricks. Mostly, I use 3 nodes actually. That is composed of 2 worker node and 1 driver node. And you know, I try to use many different instances, but I believe that M3.xlarge is good enough for my classes that is composed of about 30 students. And to use GPU, I also use G4dn.xlarge instance. And mostly I deliver the concept of how to improve the performance to the students. So I teach how to improve the accuracy and how to shorten the computing time and how to use the GPU with the traditional machine learning algorithm and also with the XGBoost and deep learning algorithms. So at the end of a semester, we have a group project for a final term project. And the minimum requirement to, I ask the group of the students to collect the data from many places like Kaggle or from companies, and also from social media like Twitter or from City of Los Angeles. And the minimum requirement of data size is 2 GB. And sometimes the students collect the data that is about 90 GB. And then based on this model, they build a model to predict the trend. And the trend, for example, like, they build a model to predict rating using Airbnb listing dataset or with the Amazon product dataset. Also for fraud detection, they collect data like ad hoc dataset or transaction dataset, and also to find out the traffic jam to classify, to build a classification model such as binary or multi-class classification model. They use the Waze dataset. So, students have many the interesting idea to collect the data and to build a model to predict something. And then, we also publish papers based on this approach. And in 2019, we one of our graduate students get outstanding paper award in a conference. And also, it is very helpful to use the Databricks notebook to visualize some result. For example, using a random forest to find out the traffic jam classification with the five traffic jam levels. We can create like a confusion matrix like this, so we can tell how accurate our model is. And also, we do the traffic jam analysis in Los Angeles. We do temporal spatial analysis that shows the traffic by time and location in Los Angeles. And this is simply use Microsoft Excel based on the result from Databricks. So in summary, based on my the experience, it is very helpful to use the Databricks because that's very easy to use, and we can start with the community edition with a small data set, and then once the students become comfortable to use the community edition, we can use enterprise edition. So we can even use large scale data set with it. Yeah. Also, I love the collaboration with any of you here. So if you have any the collaboration the interest, then please let me know with this email. Yeah, you could ask me any question. Thank you.
All right. Can everyone hear me okay?
Yeah, thank you, John. We'll send it over to Ben now, and questions in the chat.
All right. Thank you, Rob. I'm sharing my screen.
And Ben, when I introduce you, I've got like 4 things that I could mention: father, entrepreneur, tenured faculty, adjunct faculty, consultant. So I just put Bowie State, and oh, good. See, I got it right this time. So thank you, Ben. Take it away.
Awesome. Thank you, Rob. Excellent. All right. So really happy to be here. As Rob mentioned, I am currently an assistant professor over at Bowie State University. I'm also in the past life, I worked as a brickster over at Databricks, where I worked on artificial intelligence, machine learning, and working with customers to kind of help them build out these data engineering and machine learning pipelines in their organizations using Databricks. So I come from that environment, and now I'm bringing that knowledge and expertise really to the classroom at Bowie State University. So I currently teach in the Department of Technology and Security. We have a Internet of Things and Internet Technologies master's degree program. And specifically what I'm going to talk about today is CTEC 651, which is an IoT digital streaming repositories class. And it's completely taught within Databricks with a focus on real-time data analytics and streaming data. All right, so we talked about the IoT and IT program, but really what we're trying to do is, as you all know, there's just this plethora of IoT data that's going to have to at some point be analyzed within different organizations that are, focused ranging from healthcare to agriculture. So we're really trying to build, this program with the idea in mind to, cultivate these, these skill sets within the students. Where they could go in these organizations and have the hands-on experience to hit the ground running, where they're analyzing kind of real-time data, building streaming infrastructures, and really with a data science mindset on how to interact with this real-time data. A couple of things that we do within the program, and we're trying to really focus the students on is really the end-to-end pipeline. So it's not just coming in and focusing on the data science aspect of analyzing the data after it gets to, right, like a Delta Lake house, but it's more of, how do you approach the problem with an end-to-end mindset where that, there's some data that you're going to need to capture from these devices, but how do you build the pipelines all the way through Azure Event Hub or Azure IoT Hub, which is the gateway into, like a streaming infrastructure like Kafka or Kinesis, into then, creating your stream with, Spark streaming, all the way into pushing that into a Delta repository, right? So we're focused on that end to end. But we're teaching them Spark streaming, the streaming API, the data frames API, Spark SQL, because not only do we want them to understand how to get the data in, but it's about the analysis and how to, analyze the data, present it, so they can be useful for data-driven decision making as well. So we're using the stream processing with Apache Spark as the book, but we also use a separate book that really focuses in on, from a hands-on perspective, how do you, connect into the Azure IoT Hub, create some simulated data that can simulate, multiple IoT devices. How do you pick that up in the IoT Hub all the way through sending it into using Spark streaming to send it into a Delta Lake? So those end-to-end concepts are what we're teaching, but we require them to have at least some knowledge of SQL, NoSQL databases, and an understanding of what a distributed architecture is. But we really focus on those core fundamentals. So you can think about like core Spark, all the way from like the core concepts of, the drivers to the tasks to the executors, but all the way through to, all right, once you understand the infrastructure of Databricks, now how do you start to, wrangle data and create data pipelines? And then how do you more specifically focus on real-time data? So we jump into, all the core aspects of Spark streaming, but with the goal of really just teaching them, when you think about data coming in real time, we want them to understand, not only the material aspects, but the, more of the additional non-material aspects of, kind of legal and ethical and social issues associated with kind of real-time streaming data from these IoT devices as well. Now, from a project perspective, so kind of the core structure. So we have, it's 2 projects, so it's a lot of project-based learning. They do discussions where we focus on, some of the implications in industry, right, for real-time data pipelines and kind of real-time streaming and streaming infrastructures. They do case studies where we're looking at, organizations that have, are creating real-time data sets that they're pushing into, some of these repositories, doing analysis. We're having the students look specifically at how these are actually happening, where we're bringing in subject matter experts to talk about, these case studies in the classroom. And then one of the cool things, so I worked at Databricks, and in order to, to work at Databricks in a technical capacity, you had to take a coding exam. So, so Rob, you might have to help back me up on this one, but I tell the students upon successful completion of my coding exam, they should be right on par to come to Databricks and be successful, pass that coding exam, and be right on par to, kind of build that pipeline into Databricks. So I'm getting them ready, Rob, in a sense, to pass the coding exam that's on the Databricks side once they get to that point. So really in an effort to, because we really want our students to, not only use Databricks, but, we'd love for them to work for Databricks as well. But so we do have, like this coding exam where literally I set up, challenge problems inside of notebooks that deal with Spark streaming. And part of their exams, I give them a week, 5 days to go over these challenge problems in Databricks. And after the 5 days are over, I go into Databricks and I check their notebooks and kind of grade them directly in the actual Databricks platform. So when we think about the projects, is really, we do some data simulation, and Azure IoT Hub does a really good job of helping us simulate thousands of devices. So the student's job is to, either through, in Azure, it's Kafka, working from Kafka to, leveraging Spark to push it into like a, data lakehouse, all the way through visualizing the data or running analytics or machine learning on top of the results that are stored in more like a warm or hot style database, but batch machine learning if they're pushing it to more of a like a colder database. But the opportunity for them is learning how to view the data in real time with using a visualization tool like, Power BI, but also at the same time using machine learning over batch data that they're storing in a centralized repository as well. So as far as how we set it up, so I like the comment, we push them out to the students out to the community edition first to get them, the knowledge and experience working in that environment. We set the students up with a workspace account where they're, within the Databricks environment. So we set them up physically as a second step in the environment. We get them Azure because we have to simulate the data in Azure from the devices that they'll be picking up using Spark Streaming. The students are assigned in the groups. We basically create 3 clusters with the goal of trying to manage how much resources are being used. So we don't give them the full ability to create, any size clusters that they want. And we point them to a streaming cluster, data science cluster, machine learning cluster, and a GPU cluster. And then each group has their access right to the, S3 or ADLS Azure Data Lake to actually store the streaming data after it comes in. And then we use, as I mentioned, Azure IoT Hub for the data simulations. They can use, direct connection into the Databricks notebooks, or they can connect to Jupyter. And then we do, as we build out the containers that are associated with the underlying clusters, we do build them out with the libraries that are necessary to be successful in the class as well. So you don't have to worry about like just the cluster orchestration of the libraries being present. We handle that as well.
Hey Ben, can I ask
yep.
a quick question about how the Azure gets provisioned for the students? Is that like a centralized IT account? How do you get those resources? I've had SMU use Azure, but it's the free Azure student accounts, and then they can't connect to the proper clusters. So if you have 2 seconds on that background, that would be helpful.
Yeah, no, that's great. So the challenge, you hit it on the head. So even internally in our course, when we're building out the projects, so that book that I quoted has really good resources for understanding how to connect to the different services in Azure. The challenge was for us as well is that when you think about connecting to Azure IoT Event Hubs or Azure Event Hubs, Azure IoT Hubs, you've got you're trying to create a connection to Kafka, which allows you to then work through Databricks with the Spark Streaming APIs, but you also might want to connect to a service, a Power BI service internally in the Azure environment as well. So the challenge is that the student accounts don't give you kind of the full provision to all of those services that you need to be successful in the projects. So what we had to do was, as a department, is we had to allocate an Azure account, right, specifically for the department. And what I do is I provision the students within that, department-wide Azure account, right? So it's a little bit more on the risk side of the house because, certain students have more experience in those environments. So you're trying to build as many controls as possible. But without it, it's really hard to get access to the services that you'll need to really, have a successful end-to-end project in a class like this, where you can't do everything in Databricks, and we're trying to teach them the end-to-end. So you have to interface with these other services inside of Azure to do that. So getting the department-wide account and provisioning the access to Azure was really helpful for us.
Thank you.
Okay, and then I teach 2 other classes. They're all Databricks focused. One is at George Washington, data analytics or data science, and the other one is a scalable computational bioinformatics. So I think it's one of the first bioinformatics-based Spark courses that was ever created. So doing that at Johns Hopkins as well. So that's it. Thank y'all very much.
Thank you so much, Ben of the many hats. He and I both have children in the early years of elementary school, so occasionally we share stories. I think the latest, Ben, is the messages that come out about strep, COVID, pink eye, and it's just like it's an epidemiological petri dish. So I'm glad you're healthy and strong.
Yes, sir.
One of the most important, there's two aspects I think that every speaker has touched on so far, and I love seeing the diagrams from each of you, how you talk about the architecture. And we excuse Ben's complex diagrams because he used to work for Databricks, and that's what we have internally on our corporate decks. But you can teach students fundamentals of data science. We all, I think everybody on this call knows that the students enter their class with some idea of the fundamentals. It's really the flow diagrams, like, Ben, you focused on streaming. It's like, it's not just reading a file into Community Edition and it's a CSV file and then we mess with it. It's like, oh, the real world keeps intruding with its messy data on the stuff that we're trying to build. That's a huge skill. It's like being an adult. It's like the world keeps intruding on the things that you want to get done. Knowing how to handle that is a big deal. And then the other piece, like we touched on with Su Hong, is there is no optimal, as your model changes, as your data changes, maybe how you provision your clusters, maybe the cluster you choose, all of those things, it's a cost benefit trade-off. And the initial conversation in any capstone project should be, what's the business value that we're trying to build here? In other words, what's the positive? If we look at ROI, it's a numerator and a denominator. What's the numerator? What are we shooting for here? And what are the costs involved with trying to achieve that numerator? And making sure that they understand this process is kind of messy and it's iterative. And we've got some streaming things and we've got some scaling things. And oh, we have to do some featurization. And oh, we have to track how our model grows and evolves over time. All of those things, all of the professional data scientists that I've talked to, and I lump analysts and engineers in that category as well, they're like, oh my gosh, I have to train my own internal people on this stuff. So I get excited about this, this capstone idea because it starts with business value. It forces students to think through the whole architecture diagram and think about all of the trade-offs along the way, whether it's, and we all know the trade-offs off the top of our head. So thanks. It just gets me more excited. I think I'm working on the right things for the community when I hear these. So I'll turn it over to Diane. We've got roughly 17 minutes left in the call. So Diane, feel free to take the time that you need. And I think we've gotten most of the Q&A along the way, but I want to save at least 5 minutes at the end for general. And I guess the other thing is we can see the value of a Vocarium in this situation, because then, hey, you want to use Azure? Great. You want to use AWS? Great. Abstracting another layer away from figuring out how to provision and budget those resources is huge. And my favorite story is 3 months into my job at Databricks, we worked with a master's in data science class at Berkeley, and they spiked to be about $25,000 of AWS in one semester. And I remember those budget discussions. We had to lock down the AWS account on a daily basis to make sure that they had enough credits, and this is IT internal credits plus whatever credits I could give them to make sure they didn't go over budget. That's a real thing. And one other thing I'll mention for the audience, it's my favorite sort of talking point from your aggregated experience. If you're going to use the full Databricks platform and cloud resources on the back end, it averages from $2 to $7 per student per week. So $2 to $7 per student per week, a sort of a middle of the road, no deep learning, no GPU. So if you have 30 students and it's a 14 to 16 week course, it's, $1,000 to $2,000 of cloud credits. And that's just a good number to have in your head if you're moving from Community Edition to enterprise. So anyway, I'll stop talking. I could talk forever. Diane, please take over, and I'm going to go on mute.
Okay. Thank you for this opportunity. I'm Diane Woodbridge. I'm the program director and also associate professor in the Master in Data Science program here at the University of San Francisco. So in this talk, I will talk about our student population. Just wanted to give you some of the background about who I'm teaching. And also example courses that I'm teaching and the motivation why I started to using Databricks, and also share 2 student projects that was done, one in last year and one in this year. So every cohort, we are working in a cohort base. So every cohort, we have over 80 students, about 80 students plus minus maybe 2, with diverse undergrad major. As you can see, this year students, about 29% students has an engineering degree in their prior education. But also, you can see that many of the students have a non-STEM related degrees as well. Like here, the other indicates like we have an English major, history major, and journalism, and many others. So not everyone has this either STEM background or the strong programming experience, but they come into our program, which is a 12-month program, and take courses that we require to, and then being in a place that they are comfortable to writing program. So after they take about 9 courses in the program, I start offering the distributed computing and also distributed data systems. Both courses are required for all our students. And again, at this point, they're pretty comfortable to writing Python program and understand how program or the computing works. So the learning objective for the second course, distributed data systems, is covering the Apache Spark and then also distributed data bases, focusing on NoSQL, MongoDB, and it requires some of the project developing a end-to-end ETL pipeline. So in the course, we have a small classroom toy project, but also students are required to develop their group project based on what they are interested in working on. For this year's example, we call the APIs regularly by using the Apache Airflow and store the raw data in the Google Cloud Storage. Some years we use the AWS 3 as well, but there was some hiccups for getting credits. I will talk about that issue in a minute. And then they do the data cleansing, pre-processing using Spark, and then store the aggregate in MongoDB. And once data is clean, they apply Spark MLlib for building a machine learning model. So in this course, I cover Spark Stack, including the Spark Core, and also Spark SQL and Spark MLlib. So a lot of basic portion, like teaching how the API works, and also some of the tricks to improve the efficiency, such as how many partition you'd use, what kind of partitioner you'd use, or how you'd cache it, things like that. Those can be done on their local machine. It is easy to do using the Jupyter Notebook. But once we move into the bigger data set, or for their classroom project, they definitely need to have a more powerful machines, which is like they really started to seeing the needs of the distributed computing that connects multiple nodes of computers and running the Spark job. So previously, between 2016 to 2021, we used to use AWS EMR, as many mentioned previously. I guess in order to running the EMR, I had to teach how how the EMR is created, including how the EC2 instance works, and how would you create the IAM for the group, and configure the security group and many other things. So even starting a cluster takes many steps in order to start a project. And it gets more complicated once you need to configure your cluster, or in order to install third-party library. For instance, last year I used the H2O AutoML in the classroom, but then this is a third-party library, and let's say after 1 hour, all of a sudden, like notebook shuts down. Then you have to go to the your master node, figure out the master node and the SSH into it, and then configure in order to change the heartbeat of the your Spark as well. So it has a lot to configure. And also there's no functionality to terminate your EMR cluster once the I guess the node is idle. So I have this story that students comes after the break and saying, I forgot to terminate my EMR and I have like $3,000 charged in my account. AWS is always understanding about this mistake, but then they had to contact the customer service explaining what happened and follow each step in order to avoid the next incidents. But it always being really dramatic and emotional in those conversations. So I started to seeing the needs of having more easy to use cluster, including the reducing the time for knowing about the system itself. In that sense, Databricks was perfect. To be honest, I had this fear that is using the Databricks, do I have to manage Databricks account and also manage my AWS or GCP account as well? But to be honest, what I found is that it hides all those complexity and work really smoothly. So once you have create the Databricks account, you can choose AWS, GCP, or Azure, and it links to your account, and then do all the configuration in order to start your cluster. So it has been really smooth, and I had to less focus on how to configure or start the cluster itself. And it is really easy to configure. For instance, installing the third-party library is just if you click the button and finding the right library, it will do. And even it is very easy to install a third-party like jar file. In the previous slide, I show you that the Spark needs to talk to MongoDB. In this case, you need to install a Maven jar package for the MongoDB and Spark to talk to each other. And that could be also done by the clicking and searching the jar file. So it has been really easy, and it takes care of everything for you. And also the best thing that I found is that when you're launching your cluster, you can decide how long you will give for terminating the cluster if your notebook or your nodes are idle. For instance, let's say the building a model takes 30 minutes. Students do not need to sit on the desk for 30 minutes to waiting for it. But let's say they close their laptop, and then once the model is done, if the Databricks notice that it is idle for 10 minutes, then it automatically shuts down the cluster. So it reduced the cost hugely. And also I didn't have to deal with this students who got really upset about the $3,000 bill anymore. So I brought 2 student projects for the last year and this year. One is a Spotify song and playlist recommendation engine done by Lucas Oliveira and Chandarish Embati and Anish Mukherjee last year. They use Databricks to process the data, including the 1 million song playlist from ACM Rexis, and then also 2 million song lyrics. And they also use the Databricks with a Spark for training the embedding for their songs, and then also lyrics as well. This project is currently on the MongoDB developer page. The MongoDB that we have an alliance with thought that this project is a high quality, so they use this example as how to use a MongoDB as well. But we also, as I mentioned, benefited using the Spark in order to process the data and build a model. And this is this year's project that Johnny Chow, Amy Tang, and Matt Wheeler created a project for predicting solar radiation using weather data. So what you can see here is that if you are adding your location information and the number of panels that you're going to install, it give you the prediction for the annual saving if you install the solar panels. So they use the Databricks to, again, pre-process data using PCA algorithm to reduce the feature space, and then also use the random forest regressor for developing this prediction model, and then use for some of the EDA for visualization. So I guess mine was pretty short, but if you have any questions about my experience using Databricks, you can shoot me an email or connect with me through LinkedIn. I want to say thank you to Rob and Databricks team for supporting for our student learning. Thank you.
Thank you. Thank you so much, Diane. Diane, you're in the special category of being in the Bay Area and one of the other faculty members that I've been actually able to meet in person. So my goal at some point is to get back into the cadence of going back on the college campuses and meeting people where they are, as opposed to online. So we've got 2 or 3 minutes left. If there are any questions, just shout them out. The only thing I do want to mention, and Ben, if you're listening, give me a head nod one way or the other, but sometime in late May or early June, we'll have another one of these sessions, and we're going to focus solely on LLMs and teaching students how to build LLMs with a lightweight infrastructure. Internally, there's so many discussions, and externally with investor analysts, if we look at sort of the next phase of AI that is going to drive corporate bottom line, it is taking LLMs to sort of put a more human interface to both internal reporting and then external interfaces between customers and products. So I'll
Rob, by
announce
the way,
that.
you are talking about DALL-E, right?
Yeah, DALL-E,
Oh,
yes.
okay, I see.
Yeah, and we've got somebody at Databricks who was a researcher at MIT working on an edX course, Sam Raymond, and he's going to talk about that. But it's mostly just, hey, if this is useful and I can teach students how to interface and build their own, then the chances of them getting jobs and adding value to the companies they go to is higher. So I think that's it. If there's no other questions, I will send the recording out as soon as I get it hosted in a public location. And yeah, I'm transitioning all of these assets that we've talked about for the Databricks University Alliance program. I'm pushing them out to LinkedIn and other platforms to where they're not behind the form-based registration page. So trying to make some progress here. So on asset sharing. So thank you, Lloyd, Suhong, Diane, Ben, and Jongwook. Without your efforts, I would not wake up every day with a smile on my face thinking that maybe I'm helping people, and you are helping students, and that's where we are.
Thank
All
you,
right,
Rob.
take care.
Thank you,
Okay,
everybody.
thank you guys. Take care.
Bye. Bye.
Bye.